Thanks to the Talk Python team who sponsored this episode of the Engineered Mind podcast. If you want to learn Python and delve into exciting topics like data science, web development, or building apps, feel free to visit talkpython.fm/mind to find your next level and get a 10% discount. Also a big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast we cover topics such as engineering, artificial intelligence, neuroscience and other interesting topics to educate, inspire and engineer people's minds all around the world. I'm your host Yusuf, and for this episode of the podcast I'm happy to have Pierre Baqué on my show. Pierre is Chief Executive Officer at Neural Concept, which he co-founded in 2018. Pierre received an engineering degree in applied mathematics and a master's degree in operations research from Ecole Polytechnique in France. After working as an optimization and machine learning engineer for Credit-Suisse in London, he joined the computer vision laboratory at EPFL, where he obtained his doctoral degree under the supervision of Professor Pascual Fua and Professor Francois Fleuret. His research focused on deep structured learning and variational inference applied to computer vision. During and after his thesis, Pierre worked as a consultant in machine learning and optimization for multiple companies such as Thales, EFCables, Sonalytic and Honywell. In this podcast we talked about deep learning in engineering applications, how Neural Concept can be used for this purpose, why deep learning is so important in engineering, and a lot of other interesting aspects. For updates on upcoming podcasts, projects, and videos, make sure to follow me on Twitter as well as on Instagram. And now, ladies and gentlemen, here's my podcast with Pierre Baqué. Pierre, welcome to my show. It's a real pleasure to have you on my podcast. Welcome, first of all.
Thank you, Joseph. Very happy to be here as well.
So as always, and the audience already knows it, we get started with you giving us a 1-minute bio of who Pierre is and what he actually does.
So, hello everyone. So my name is Pierre Baqué. I'm the CEO and co-founder of Neural Concept. My background is in computer science and applied mathematics. So I studied in France, Ecole Polytechnique. Then I did my PhD at EPFL in the computer vision laboratory. So I started my PhD at the moment where deep learning was starting to become very popular in image processing and computer vision. Then I did some research on variational inference and on 3D deep learning, so deep learning for 3D geometries. And that's at this moment that I through discussions with a very good friend of mine who is working for Dassault System that we came up with this maybe idea of using neural networks and especially 3D neural networks for engineering applications. And that's how we started Neural Concept, the company that I'm now leading. Neural Concept is a company based currently in Lausanne, between 15 and 20 people working in the company, and we are developing the software for a new generation of software for computer-assisted design, computer-assisted engineering that heavily relies on deep learning approaches to shortcut many of the difficult operations and the slowness of current engineering tools. Mm-hmm. That's for the introduction, so happy to give more details afterward.
Mm-hmm. I think it was more than short, but you gave a very good introduction to what Neural Concept actually is. Could you maybe explain a little bit more detail for someone who is not familiar with neural networks and maybe engineering applications with neural networks or deep learning? What are you actually doing, and how can they use Neural Concept in case they need it for their engineering purposes?
Mm-hmm. Yes. So for someone who is let's assume for someone who knows engineering in general and simulations. So you know that you have this designer or product engineer who design a 3D design for an object. So it can be inside a car, it can be electronic components, it can be components inside an aircraft. And based on this 3D design, someone else or the same person with a different software will perform numerical simulations to analyze the physics of this design. It can be based on thermal properties, it can be based on fluid dynamics, relative properties, on structural, and so on. And the software that makes the simulation will output a result that the the user will analyze, that the engineer will analyze to understand if this design is suitable for his need. The problem is that this kind of chain that I described from the design to the simulation tool and back to the post-process result is a difficult, is a long chain for several reasons. First, you're changing formats several times, and also the numerical simulations in themselves are very, very powerful because they're really simulating the physics of things. But because they are actually really simulating the physics, they take a long time to compute. Can depend on which application, but usually it's several minutes at least or several hours. Therefore, you cannot have this interactive or fast design experience. And what neural concept does, and more generally, what thing that deep learning can bring is directly from the CAD design, use data to learn to skip completely all the simulation chain that I described, and go directly from the raw CAD design, which is used by the designer, to the post-process simulation of that. And therefore, so it's common as a cost because you need to have data, but once you have trained your model to do that, which is doable for many companies, then you can completely shortcut and have in almost real time simulation result, an approximate simulation result directly from your CAD design. So that's one thing. So in short, we are able to make the simulations very, very fast. And once you have done that, you can also have, obviously, another algorithm on top that is going to help you search the design space automatically. Because now, since that you can generate simulation results in the fraction of a second, you can generate automatically millions of different configurations and use this to generative design or optimization to find the best configuration given a set of constraints that are imposed by the engineer.
Got it. So people might ask, of course, for deep learning, you need massive amount of data. How does it work for a neural concept? Let's say a customer comes to you and he has his CAD model already prepared. I mean, your algorithm is probably already trained. Maybe you can go a little bit into depth how it actually works. Let's say I'm a customer. I come to you. I want to have some results from you, however that might look like. How does the steps look like that are involved in this process?
Thank you. It's a very good question. So first, you said one thing that many people say, that deep learning requires massive amount of data. It depends what we call massive, but it's not really the case that it requires massive amounts of data. So starting from 50, 100 cases, you can do good things compared to traditional methods like a kriging, so basically based on Gaussian processes like the recursion forest, SEMs, and so on. We have really benchmarked so us and customers a lot in the past years, as you can imagine. And so for small amount of data, let's say 50, 100, we never saw that the deep learning was really worse, even when you have a parametric representation and so on. But then as soon as you start having more than 100 data, this is that it really gets quickly better. So first, just to say, it doesn't really need a massive amount of data to train a model from scratch and things. The power of deep learning with respect to data is this idea of retraining and flexibility and what we call fine-tuning, in the sense that depending on the use case. So I would say that in 80% of the use cases that we have today, the customer starts from scratch. So we go, because it's a new application, completely different that we have never seen. We are like working on real industrial applications, and therefore shortcutting complex simulation chains that are very different from everything that we have seen before. And for this customer, he will have to generate a first batch of 50, 100 samples, already trained model, and then put it in production. But what we see is that when a customer has trained with 50 or 100 samples and seen that it starts, that he really sees a trend and he can understand the value, and he starts to understand the benefit, and he sees that, wow, by adding 50 samples, he already gets a really big improvement. Then he will usually be willing to add maybe a bit more. And the advantage is that people are usually willing to do this investment because they know that once they have done this once, then they don't need to do it ever again. It's not like with traditional methods where for each optimization case you need to create a new DOE and train a model from scratch. Here, once you have started for an application, you can keep your data and reuse it forever. Now, for the 20% remaining cases, which is like growing and growing, actually, we have pre-trained models that we have trained ourselves, or that some customers have allowed to us to reuse, or that maybe inside one company, a customer will have already trained his model and wants to reuse it. And what we see is that, let's say, for instance, airfoil. So what you can imagine, airfoil is the go-to case for benchmarking an algorithm and a simulation algorithm, right? And therefore, I think over the last years that we have worked, we have maybe 15 different airfoil cases, right? That data sets that we have worked with, and therefore we have like quite big amount of data for airfoils. And now we have seen that by using all the data and training a model, when you have a new airfoil case, you can really train a model. Like if you have a few samples, like 5-10 samples, you can get super high accuracy boost compared to if you train a model from scratch, and you will beat everything else, like if you're using the Gaussian process software with only 5 samples. So that's a bit the idea that you can really reuse your data either inside your company or across companies.
Mm-hmm. How does it look like sample-wise? So let's say I want to have a look at the quantity, let's say drag reduction, and maybe another parameter that interests me in terms of fluid mechanics maybe, or maybe topology optimization. Does the number of samples differ from use case to use case, or is it like roughly always like, as you said, maybe 10 cases needed?
Right. It really depends. It really depends on the applications, how many samples you need and how many samples you will have. It depends on the customer. Some customers are using 10, like I said, like a few samples, and some others are using thousands and thousands of them because they really want to push their optimization. So it really varies, yes.
Mm-hmm. So talking about the cases, which industries are you working in? I mean, automotive, of course, aeronautics. What else?
Yes, so as you said, automotive. In automotive, we are very specialized in tier 1 suppliers of the automotive industry, because this is all the people usually who are really pushing for efficiency, for cost, for optimization and performance. And their challenges of optimization are really related to that compared to OEMs who are more who have really challenges but more related to the integration of the whole system. Aerospace industry is a very strong industry as well for us, so we're working very closely with Airbus and Safran. And here it's like clearly pushing the performance of the designs and providing new tools to design faster and get better performances. And the last industry that is a strong industry for us is electronic design industry. So you can look on our website. We have a user who are using the tool for the design of piezoelectric actuators, and other customers several customers in the US that I cannot mention, who are also designing electronic components using our tool.
Mm-hmm. So as you probably might know, like in simulation, we always have this 3 steps process, right? We have pre-processing, processing, and post-processing. How does it look for neural concept? Can I just give you my CAD and then you just have the processing and post-processing step? Or how does it look like?
So for a training model, once you have a training model, you have an application that is tied out to you need, but basically what it will do is that you will give it your CAD in either a GS file or tessellated format, and it will give you whatever you trained it to do, so the post-process results directly. Okay, so you can drag and drop your AGS file and it gives you the post-process result. That's for the trained model. Inside the training, of course, you need to run the simulation chain, which involves pre-processing, simulation, and post-processing. But this is done by the experts who are running the simulation chain, and this is done once. And so maybe we need this automation, but it can remain an automation that is limited to a kind of a lab environment where you're training the model. And then for the deployment, you can forget about all this part.
I mean, you also briefly mentioned it in the introduction. Maybe for someone who is really not familiar with this kind of combination, deep learning plus engineering, can you maybe emphasize what is the big strength neural concept delivers for the customer? And yeah, maybe you can go a little bit more into detail.
Yes. I think it's very important to say it again. So today, with the customers that we work with, there are like this design experts and there is a simulation experts who are really separate teams. And the typical case that we see is that there are many design experts who are working on different parts of the product, and maybe a fewer simulation experts, also simulation experts, or quite a scarce resource. And there is and this kind of and the simulation experts, they are serving all the different or working with all the different departments for doing the designs, and there are like iteration loops between these two teams, and this iteration loops, the time for simulation, the automation, and so on is a serious bottleneck for the companies, and therefore once you make a design, typically you will be able to simulate it maybe only 5 times, 10 times, but you cannot really explore and inside while you're designing, anticipate what will be the result of the physics. And here, very early, using a tool like this, very early in the design chain, you can anticipate and get a preview, or a very accurate preview actually, of what will be the result of your simulation. And the designer, while designing, can already take into account the physics of the object. So that's really the benefits of real-time simulation for the designer.
Got it. You also offer, as far as I've seen, the light package as well as the expert package. Can you maybe light out the differences between those offers?
Yeah, thank you. I think it goes very well with that I presented just before with this designer and simulation expert. So the light package is the one that's the license that goes in the hands of the designer. It's a very simple to use package. It's like something where you basically, or maybe sometimes it's transparent so you don't even see it. It's hidden behind your CAD tool, or you just drag and drop and get the result of physics. It's just the module that makes a prediction of your that gives you a prediction using a pre-trained model. Right? So you give it a geometry or some parameters and predicts. This is for the light. It's again for designers, for product engineers, and so on. On the other side, there is expert package, which is for this is really for the experts. So it's for people who are simulation engineers, advanced simulation engineers. It can be data scientists as well in some engineering companies who start having data science teams inside the engineering department. It can be also like optimization experts, so people who are used to using software like Optislam, Heat, and so on. And these people will have access to so it's a platform that is very flexible, where you can lots of customization, and that gives you all the power of what you can do with the tools of neural concept and deep learning in engineering. So we have tried to make it very progressive in the sense that you can start simple and little by little grow with the software and with your usage of the software up to a point where you can train very complex models, make your customization for all the different applications, connect all your components with your different simulators, your different CAD, your different CAD design software, and so on, and make it really your own. And basically, yeah, what you do with this platform is 2 things: so train neural networks models that you will deploy then to your CAD designers. Okay, that will be then put in the end of the CAD designers. And the first thing, and second thing, that do optimization, so numerical optimization using the deep learning tools that are going one step, really, I would say even 2 steps beyond what is possible today in the traditional optimization packages.
Mm-hmm. And I also have seen on your blog post that you really do amazing stuff. It's really, really nice to see that. And I also know that you had a collaboration with AirShaper, with Voter, right? Mm-hmm. Do you want to talk about that, what you actually did, which is really interesting to me?
Mm-hmm. Sure. So, maybe I can give a bit of story of the collaboration with AirShaper. So we at the beginning, we were working with this company, Sensefly, with the part of Parrot, of the drones, and they wanted to use our tool to optimization of a drone, right? So the aerodynamics of the drone. And basically, we started doing optimization using all open-form scripts for simulation. And we are not simulation experts, so the optimization was very, very promising, and it was giving good results according to OpenForm. But the customer said, okay, it looks very interesting. It's performing well according to your OpenForm setup, but now we need to go like with a real professional level simulation and the simulation that we trust and that we know work. And that's why when they introduced Sensefly, with whom they were also working in parallel, and saying, okay, we would like you two guys to basically to connect the neural concept optimization tool. And this optimization tool, it needs to be fed with simulations to exist, and it's just optimizing based on external simulations. So we connected the optimization tool on neural concept with the simulations from AirShaper, which are the simulation that the customer was actually interesting. And that's how this collaboration started. And we did like, it was also one of our early projects. So we really did a nice setup, and we basically connected the API of AirShaper to the engine of neural concept, and our optimizer was using the API of AirShaper over the web to ask for new samples and get simulation results during the optimization loop. Mm-hmm. And that way we optimized the design of this drone, and you can look at the report, but it has quite big improvements in performance.
Mm-hmm. I'll link it anyway down in the description so everybody can have a look at it. I also said that you hold 2 world records. Do you want to talk about that? I'm quite interested in
Yes. So it's another of the projects that we did. Another of the early projects that we did was that we worked with a bicycle team, which is based in France, in Annecy, and he's working also with Mavic. So it's in Annecy, like the University of Annecy, and with Mavic, they are like a very famous producer of bike components. And basically their challenge was to design a very high aerodynamic shell for a bicycle in order to try to beat the world record in human powered speed. So basically it's a challenge in Nevada every year. You have 8 kilometers to accelerate as fast as it's very flat, it's a long road, and you have 8 kilometers to accelerate, and your speed is taken over the last, as an average, over the last 200 meters. And like one of the core challenges here is to have an extremely aerodynamic bicycle, because you can reach speeds that go up to 136 kilometers an hour, which is what this bicycle reached. And we collaborated with this university using also optimization algorithms based on deep learning and so on. And we came up with a design that was produced, and that actually broke 2 world records, so the female world record of all time, and the male university world record was also beaten during the same session using the same bike.
Really interesting, yeah. Mm-hmm. Where do you see, maybe we split it into 2 parts, which is also the last question before we wrap things up. Where do you see deep learning going into the future when it comes to generative design or engineering applications? And can you maybe if you want to give it away already, where do you see neural concept going into the future?
So where will the deep learning go? So I think that the application that I described today, so shortcutting, simulation, chains, and optimization will become more and more used and more and more prevalent. Because also the ecosystem around will be more and more adapted to that. So the data, people will start actually gathering their data. It's like so often that we meet the customer and they don't know, oh no, we never recorded their data. Okay, now we will start recording them. So people will have more and more data available. And I really think that this kind of approaches using 3D machine learning and engineering is going to also put a bit everywhere. It will bring tools that will simplify everything, simplify the life of engineers to go more straight to the point, because there are so many small applications that you can, small things that you can fix using the power of machine learning to shortcut things. So that's for deep learning, for neural concept. So now the company is growing at a measured pace, but a constant pace. Our goal is just to make tools that engineers like and that are useful for people, and that are doing new things that were not possible to do before, and putting these capabilities in the hand of more and more people. So that's the goal of the company in the future. And I don't know where it will take us as a business, but our focus is really on the value that we provide to the users.
Mm-hmm. How can people reach out to you? And do you have a careers page where people could apply if they're interested in working with you?
Yes. So you can look on our website. If you want to contact us, there is a contact tab. You can reach out to me on LinkedIn as well. No problem. Or if you reach out to Joseph, he can give you my email. So that's no problem. We will find ways to reach out to us. Regarding applications for future careers, yes, you can find on our website there is a tab with job offerings. Feel free to have a look, and there are instructions to send your CVs. So yeah, please go ahead.
That's great. Do you also offer some kind of trial phase if people want to use neural concept?
No, so we were doing this in the past, but we realized that we wanted to be engaged and committed on the side of every customer that is using the tool.
Yeah.
It's a very powerful tool, but also very that needs care to be used, and therefore we prefer to have a personal relationship with every person who's using the tool, and progress in that way. Therefore, if you're a company or engineer and you want to use it, reach out to us. I'm sure we will find a way for you to start using the tool. But there is no free trial license that we can just
That makes absolute sense, Pierre. With that being said, I thank you so much for being on my show. And if people want to reach out to you, I'll put every link to Neural Concept down in the description. And as Pierre already mentioned, if you want to reach out to him or don't know how to reach out to him, I can provide the email to you. That's fine. And you can also find him on LinkedIn as well as his whole team. With that being said, again, thank you so much, Pierre, and hopefully see you in the second part in the future. Who knows?
Thank you, Joseph. Bye-bye.
Thanks. Bye-bye.